Yeah. Hi guys. So we are done with our doubts clarification. Now let's get started with another concept, stateful containers versus stateless containers. Stateful containers and stateless containers, right? So now containers are two types. One is stateful container and another one is stateless container. Already in the Docker, we understood what is a stateful container and what is stateless container. So stateful containers, nothing but they will maintain our data permanently. So whereas stateless containers will not maintain our data permanently. Now here, let's understand what is stateful container and what is stateless container. So now, what is stateful container and what is stateless container? Let us try to understand. So here we are deploying our application on the Kubernetes cluster, guys. We are deploying our application on the Kubernetes cluster. So containers will be created. The containers are creating inside the pod. So stateless applications cannot store the data permanently. For every request, they will get new data and it will process that data. So every request will be considered as a fresh request when you go for stateless application. For example, when you deploy a Node.js application or when you deploy Nginx application or Spring Boot application, those applications are by default stateless applications. Stateless applications cannot store the data permanently. For every request, they will get new data and it will process that new data. Every request will be treated as fresh request. Every request will be treated as fresh request or new request. So now the applications which are not storing the data permanently, those applications are called as stateless applications. Node.js applications, Nginx applications, boot applications, those all are stateless applications only. Then what about stateful applications? Stateful applications means they will store the data permanently and they will keep track of the data. Right. Now, for example, if you go for a MySQL database, so once we insert the record into the MySQL database, that record will be inserted permanently in the MySQL. MySQL, Oracle, Postgres, like that, there are several databases are available. So database containers we are going to deploy on the Kubernetes. So when we deploy database containers on the Kubernetes, so that those containers are going to maintain the data. So the application which is remembering the data is called as a stateful application. The application which is not remembering the data, that is called as a stateless application. Now in the Kubernetes, guys, we are having two things here. One is deployment, and second one is stateful set. There is a concept called deployment is available and another concept is called stateful set is available. So deployment will be used for stateless applications. When your application is stateless, then we will go for and deploy that application by using deployment approach. When your application is having some state, right? If you want to deploy database in the Kubernetes cluster, then to deploy the database in the Kubernetes cluster, stateful set is the recommended approach. When you are deploying your front-end application or back-end application, then we will go for stateless application. When we are deploying database containers, we will go for stateful set. Sir, what is the difference between this deployment and stateful set? So deployment is one Kubernetes component. Stateful set is also one Kubernetes component. By using deployment, we can deploy the application. By using stateful set also, we can deploy the application. But here, if you observe, when we go for the deployment, it will create the pods with a random pod name, right? Suppose my application is having Java web application pod and some random name it will assign for the pods. So like this, I want to create 3 pods. So 3 pods will be created with 3 different names. This is a random pod name will be assigned when we are going with the deployment concept. When we are going with the deployment concept, right? Now like this, so the pods will be created. So deployment. And whenever I want to scale down my pods, in the deployment, in the random order, one of the pod will be deleted. In the random order, one of the pod will be deleted. So when you go for deployment concept here, deployment will create the pods with the random IDs. Deployment will scale down the pods in the random order, and the deployment pods are stateless pods. So I will show you practically. Yesterday, we have deployed our application and we deployed database also. Yesterday, our database is deployed with the deployment approach, but actually deployment we need to use for stateless application. And when we are deploying database in the cluster, the database deployment we need to do with the stateful set. Let me show you the difference. Let me show you the difference. Now, let me connect with my client VM to access my cluster. EKS client VM is available. By using that EKS client VM, we are sending the request to the control plane. This is my client VM. Let me access its public IP, mobile extram, SSH, remote host, username is Ubuntu, and SSH settings, private key. Okay, now select this. Good. ls-l. So we are in our client machine. Let us go into Kubernetes manifest files, cd Kubernetes manifest YMLs. In that, our folder is available, cd space 03. Now, I'm in this deployment manifest YML location. Here, if you observe, kubectl get pods. Now, how many pods are running? For the database, one pod is running. For the application also, one pod is running. Now I want to increase my pod count. You can do the scale. So you can do kubectl scale deployment, -replicas count you can increase. So kubectl scale deployment. What is the name of the deployment? So this is the deployment name, -scale, scale replicas, sorry, -replicas. I'm giving as 3. Now server deployment not found. Sorry, this is not the pods, guys. kubectl get deployment. Now, so these are the 2 deployments, and you can see kubectl get pods available. For these are the deployments that I have created, and these are the pods. For application, 1 pod is running. For the database also, 1 pod is running. Now I want to scale my deployment. kubectl scale deployment. This is my deployment name. Okay, -replicas 3. Now deployment got scaled. Now once the deployment is scaled, now you see kubectl get pods. For the database, how many pods are running now? Guys, for the database, how many pods are running? Earlier, 1 pod is running. Now 2 more pods are created. Let us check that. kubectl get pods. Now you see my application is having 1 pod and my database is having 3 pods. Now, if you see the database 3 pods, vShopify app DB deployment is my deployment name. And for the pod name, vShopify app DB deployment -, some random text, some random text. This is called pod ID. This is called pod ID. So whenever we go for the deployment will create the pods with the random IDs, and the deployment will scale down the pods in the random order. Deployment pods are stateless pods. Now, if you observe, my pods are created, 3 pods are created. Currently, 3 pods are running. Earlier, when I execute the command, kubectl get pods, I'm able to see only 2 pods. In those 2 pods, 1 pod is related to my Spring Boot application. Another pod is related to my MySQL database. After this, manually I have scaled the deployment, kubectl scale deployment. This is my deployment name, replicas 3. From 1 replica, I'm making 3 replicas. When I execute this replicas 3, after that, when I see pods, now I can see Spring Boot application running in 1 pod. My database is running in 3 pods. So that means I have scaled. When I scaled it, you see the pods. The pods are created with some random IDs. These pods are created with some random IDs. Now here, whatever the pods that we are creating by using deployment, random IDs will be assigned for the pods, and those pods are stateless pods. Now, but in the reality, when we are deploying the database applications, we need to go for stateful containers. So to create the stateful containers, we are going for stateful set available in the Kubernetes. So what is a stateful set? A stateful set is the Kubernetes controller used to run stateful application pods in the Kubernetes cluster. Whenever you want to deploy your application in the cluster, and if you want to maintain the data of that application, then we need to go for stateful set, but not the deployment. You see here, browser is there. From the browser, user will send a request to application. It can be Node.js, or it can be Python, or it can be Spring Boot. Whenever request comes to this Node.js application, that will talk to database. My Node.js will not remember any data. This Node.js application or Python application or Java application or Spring Boot application, these are stateless applications. Request will come, they will process the request, they will store the data in the database, they will send the response. After request processing is completed, this Node.js application will not remember the data, but database will remember the data. Database will store the data. So here, the application which is not remembering the data, that is called as a stateless application. The application which is remembering the data, that is called as a stateful application. So now here, we need to deploy application with stateful containers and stateless containers. When to go for stateful container and when to go for stateless container? If you are deploying the database of our application, then we need to go for stateful container because database should remember the data. When we are deploying our boot application or Python or Node.js backend applications, those applications we will deploy as stateless application. Our front-end applications also will be deployed as stateless applications only. Now here, in order to deploy stateful and stateless applications in the Kubernetes, we are having two things. One is the deployment available. Another one is stateful set is available. Deployment is used to create the pods with some random pod ID. Now here, 3 pods are created and 3 pods are having 3 different random IDs. Now, let me show you here. kubectl get pods. Now here, if you observe, 3 pods are created. Earlier, there was only 1 pod for the database. Now, 3 pods created for the database. Now, I want to scale down my deployment. When I scale down my deployment to 2 pods, kubectl scale deployment, application DB deployment, replicas 2. Currently, for my database, 3 pods are running. I'm giving the replica as 2. Guys, if you observe, am I scaling my pods? Scale up? Am I doing the scale up or I'm doing the scale down now? I'm trying to increase the pods or I'm trying to decrease the pods? I'm trying to increase the pods or I'm trying to decrease the pods? I'm trying to decrease the pods. So from these 3 pods, which pod will be deleted? From these 3 pods, which pod will be deleted? Any guess? Any guess? No, random. So that is deployment. When you go for the deployment, they don't give any importance for the pods. Random ID will be generated for the pod. And whenever you scale down, from these 3, any 1 pod can be deleted. Any 1 pod can be deleted. Okay, replicas 2. I have done scaling. Okay, I have done the scale down. 3 pods available. I reduce it to 2. kubectl get pods. Now you see here in the database, yesterday in the database we have 3 pods. Earlier we have 3 pods for the database. Now I have scaled down to 2. 1 pod got deleted. 1 pod got deleted. Do we have any control which pod will be deleted from these 3? It is random. So deployment is going to create the pods with the random ID and it is going to scale down the pods with the random order. But when you go for stateful set, it will not happen like this. When you go for stateful set, for example, I want to create MySQL DB 0. If I want to create 3 pods for the MySQL DB 1, and MySQL DB to like this, it will create the pod with a sticky identity. When you go for the deployment, pods will be created with the random ID, whereas in the stateful set, the pods will be created with the sticky identity. You see here, when we create the pods by using deployment, then if I give 3 replicas, 3 pods will be created. All the 3 pods will have the random ID. But when you go for stateful set, when you create the pods by using stateful set will create the pods with the not random ID, with the sticky identity. First pod will be created with the identity 0. Second pod will be created with the 1. Then third pod will be created with the 2. So sticky identity will be available when we go for the pods in the stateful set. And here, when I scale down the pods in the stateful set, always it will delete the pods from the reverse order. Always it will delete the pods from the reverse order. We will have full control on our pods. So when the pod should be deleted, which pod should be deleted. So the pod which is creating with the 0, this is called as a primary pod, and these pods are called as a secondary pods. Primary pod will be available and the secondary pods will be available. So when you go for the deployment, every pod is same with random ID pod will be created. And when we scale down the pods, randomly one pod will be deleted. But in the stateful set, it is not like that. In the stateful set, the pods will be created with the sticky identity. And whenever you delete the pod, always the pods will be deleted from the reverse order. The first it will create the primary, then it will create the secondary. Whenever you scale down, secondary pods will be deleted, then only primary pod will be deleted. Okay, now observe what is stateful set. So stateful set is the Kubernetes controller which is used to run stateful application pods in the Kubernetes cluster. Stateful set assign a sticky identity, a ordinal number starting from 0 to each pod instead of assigning random ID for each replica of the pod. Whenever you go for deployment, random ID will be assigned for the pod. When you go for stateful set, a sticky identity will be assigned for the pod. So that is what we are telling here. Stateful set will assign a sticky identity, an ordinal number starting from 0 to each pod instead of assigning random IDs for each replica of the pod. So when you go for the deployment is assigning a random ID for each pod, whereas stateful set will assign a sticky identity for each pod. As the new pod is created by cloning the previous pod's data. If the previous pod is in the pending state, then new pod will not be created. If you delete a pod, it will delete the pods in the reverse order, not in the random order. Whenever you go for stateful set to create the pods, first primary pod will be created. Whatever the data is available in the primary pod, by copying that data, secondary pod will be created. By copying the data, third secondary pod will be created. Whenever you delete the pod, whenever you scale down the pod, it will delete the pod in the reverse order, not in the random order. So are you guys able to understand the difference between deployment and stateful set? Guys, are you able to understand the difference between deployment and stateful set? Yes. When we need to use the deployment and when we need to use the stateful set. When we need to use the deployment and when we need to use the stateful set. For example, here if you observe, we are going to deploy MySQL database by using deployment concept. 3 pods I have created. Now assume that here MySQL database is available. Here MySQL database is available. Here MySQL database is available. DB pod 1, DB pod 2. DB pod 1, DB pod 1, right. And this is DB pod 2, DB pod 2, and DB pod 3. DB pod 1, DB pod 2, DB pod 3. So 3 pods available for running my database. 3 replicas available for my database. Here my application is available. This is my Spring Boot application pod. This is assume that my app pod. My app pod is sending some request to the first pod, inserting some data, sending the request to the second pod, sending the request to the third pod. Now, So the data is inserted in the first pod database, So how many copies of database created now? 3 copies of the database is created. 3 DB containers are running. That means here DB pod 1, this database available, here database available, here database available. DB pod 1 connected to this MySQL database, connected to this MySQL database, connected to MySQL database. Clear? My application is communicating with the database now. For the database, 3 pods are available. So when I deploy the database with the deployment approach, 3 random pods are created, random IDs are available. Now assume that this is my pod ID, first pod ID, and this is my second pod ID, and this is my third pod ID. Okay, 3 pods are created. That means 3 databases are running now. Application sent a request. I inserted 1 record. So my record 1 is inserted here. My record 2 is inserted here. My record 3 is inserted here. After that, what I have done is I have scaled down the database from 3 pods to 2 pods. When I scale down from 3 pods to 2 pods, then what it will do? It will delete 1 pod in the random. For example, this pod is deleted. This pod is deleted. Now I lost that data. What about the second record now? I have deleted my pod. I have scaled down my deployment. Database I deployed with 3 pods, 3 random ID with the pods created, 3 pods created with the random ID. I have inserted 3 records. 1 record inserted by first pod, 1 record inserted by second pod, 1 record inserted by third pod. After that, I realized that 3 pods are not required for the database. I scaled down to 2. When I scale down to 2, which pod will be deleted? Random. So it deleted second pod. Assume that. If it is deleted the second pod, then what will happen? If I delete the second pod, if it is deleted the second pod, then what will happen? If it is deleted the second pod, then what will happen? Data loss. Data loss. So is it recommended to go for the deployment to create stateful containers? Is it recommended to go for deployment to go for the stateful containers? Not recommended. Not recommended. Okay, guys. So here, why the deployment is not recommended? I hope you got the clarity now. When you go for the deployment, the pods will be created with the random ID and pods will be deleted in the random order. Pods will be created in the random order. Pods will be deleted in the random order. So when the pod is deleted, we will lose the data. So that is the reason for the stateful applications, deployment is not required. So deployment will be used only for the stateless application. Now, same concept, if you are going to implement with the stateful set. Same concept, if you implement with the stateful set, then what will happen? We understood what is stateful set. Stateful set is the Kubernetes controller to run the stateful applications in the cluster. Stateful set will assign a sticky identity, an ordinal number starting from 0 to each pod, instead of assigning random ID for the each pod. A new pod will be created by cloning the previous pod data. Okay. Now, if you go for stateful set here, it will be available like this. Pod 0 will be available. Pod 1 will be available. For every pod, PV and PVC will be available. So yesterday I gave just overview. PV represents storage. PVC storage permission. PV PVC will be created. PV PVC will be attached to pod 0. PV PVC will be attached to pod 1 also. Pod 0 will be created and pod 1 will be created. Here, pod 0, pod 1 are called as stateful set pods. Pod 0 is a primary pod. Pod 1 is a secondary pod. Now here, whenever you go for the deployment, guys, the deployment will create 3 pods. For the 3 pods, 3 random IDs will be available. Pod 1, pod 2, pod 3. 3 random IDs are available for the pod when you go for the deployment. Here, when I scale down my deployment, any one of the pod can be deleted. In the random order, pod will be deleted. But if you go for stateful set, whenever we are going to create a database container with 3 replicas by using stateful set, 3 pods will be created. For the 3 pods, sticky identity will be available. MySQL 0, MySQL 1, MySQL 2. MySQL 0, MySQL 1, MySQL 2. 3 pods will be created. In these 3, first pod is called as the primary pod and the remaining pods are called as replicas. First pod is called as primary pod. Second pods are called as replicas. Now, whenever I delete a pod, when I scale down my stateful set, is it going to delete the primary pod, or it will delete only replica pod? It will delete only replica pod. And here, when you go for the stateful set for the database write operation will happen on the primary pod. Database read operations will happen with the secondary pods. That is the another beauty in the stateful set. Even if you delete your last pod, still data loss will not be available, because the second pod is just a replica pod. It is only to read the data available in the database. Even if the second primary pod, if it is deleted, no problem. If this secondary pod is deleted, MySQL 2 pod is deleted, no problem. If MySQL 1 pod is deleted, still no problem, because MySQL 1, MySQL 2 are the just replicas of the primary. Primary pod is there. That primary pod will connect with the database to insert, to update, to delete. Write operations will happen with the primary pod. Read operations will happen with the secondary pod. Whenever you scale down the stateful set, it will delete the pods from the reverse order. First, this third pod will be deleted. Then this second pod will be deleted. Then primary pod will be deleted. So that's why when we are going to deploy stateless applications, then you will go for deployment concept. When you are going for stateful applications, then we need to go for this stateful set concept. Okay, how to represent this as a stateful set? When we are going for stateful set, right? So the stateful set we are going to configure for the DB deployment. Instead of giving the kind as a deployment, we are going to give the kind as stateful set. We will give the kind as a stateful set. When we give the kind as a stateful set, then what will happen? When we give the kind as a stateful set, then what will happen? It will create the pods with a sticky identity. It will create the pods with the sticky identity. What is the advantage? If the pods are created with the sticky identity, you see the difference clearly. In the deployment, the pods will be created with the random identity, and pods will be deleted in the random order. Pods will be created with the random ID. Pods will be deleted in the random order. So if the application is stateless, then going with the deployment is okay. But when you go for database is a stateful application. Database data is very important for our application. When we are deploying database in the Kubernetes cluster, then we need to go for stateful set. When you go for stateful set, your pods will be created with a sticky identity. MySQL 0, MySQL 1, MySQL 2. MySQL 0 is called as a primary pod. MySQL 1, MySQL 2 are the replicas of the primary. Once the primary pod is created, by copying the data of the primary, that MySQL 1 will be created and MySQL 2 will be created. MySQL 0 is a primary. The primary pod will be used for the write operations on the database. Secondary pods will be used for read operations on the database. Whenever you scale down the stateful set, it will delete the pods in the reverse order. That means MySQL 2 identity pod will be deleted first. Then MySQL 1 identity pod will be deleted. Then after primary pod will be deleted. But in the deployment, in these three, any one can be deleted in the random. That is the difference between deployment and stateful set. So from now, when you are going to deploy your database, you need to go for stateful set. When you are deploying your front-end or back-end applications, you will go with the deployment strategy. Replication controller, replication set, deployment is there. Now we understood what is stateful set. Stateful set is used to deploy. Stateful set will be used to deploy that application databases. When you go for the stateful set, we don't scale down to 0, right? So if you scale down to 0, then primary also will be deleted. If the primary also deleted, we lost the data. We don't delete the primary pods. Secondary pods can be deleted. So when you go for stateful set, data retention, data maintenance will be available. Stateful set is used to deploy stateful containers. Stateful set is used to deploy stateful containers. Now, let's go here. Now we are having our deployments, right? kubectl get all --all. kubectl get all. Now, when I go for kubectl get all, here you see 3 pods are running. 3 pods are running for the database. And here one service is running. Boot service is running, DB service is running, and boot deployment is running, and database deployment is running. And boot replica set and DB replica set. Internally deployment is using the replica set. Now let me go for kubectl get deployment. Kubectl get deployment. Deployment is there. Let me delete the database deployment. Kubectl delete deployment. I'm deleting my deployment here, guys. I'm deleting my deployment. Deployment is deleted. So with this, my database pods are deleted. Kubectl get pods. So only my boot application pods are running. My database deployment is deleted. Okay. So let me delete my application deployment also. Kubectl delete deployment. Spring Boot MySQL. Right. So with this, all the deployments are deleted. No deployments available. Kubectl get pods. Application deployment deleted. Database deployment also deleted. Now let me go for my DB manifest vi DB deployment. That is 5. DB deployment is available. In the DB deployment, what is the kind I have given? In the DB deployment, what is the kind I have given? Deployment. Let me go for this as stateful set. And replicas, I'm giving as 3. 3 replicas I'm giving for my database, and a deployment type I'm giving as a stateful set. Okay. Shopify app DB stateful set deployment. DB deployment stateful set. STS I'm giving as the deployment name, stateful set. DB deployment with the stateful set. DB pod volumes are already available. Okay. Just I changed the kind from deployment to stateful set. Now save this. Now let's apply this deployment. Kubectl apply -f DB deployment. Now stateful set missing required field service name. If you choose to ignore the errors, stateful set missing the required field service name. Stateful set spec vi YML stateful set. Kind is the stateful set spec volume match labels replicas 3 service is available. It is expecting service name in the stateful set. Let me check the stateful set YML. MySQL DB with stateful set example. Run a replicated stateful application. Kubernetes official documentation is available. That is a config map, and it is a service. Create the stateful set. Kind is a stateful set. In the specification, we need to give the service name here. Now selector is available, match labels available, replicas. Above the replicas, service name we have to provide. Now above the replicas, service name. Replicas I have given as 3, service name it is expecting. Service name I am giving as MySQL. Okay, let us apply. Yes, with this stateful set is created. For my database, stateful set is created. Let us go for the pods now. Kubectl get pods. Now guys, when I create the 3 pods, 3 replicas, is it giving random ID for the pods, or it is giving sticky identity for the pods? Guys, earlier for the deployment we have seen the pod IDs. Now you can see the pod ID. Now my pods are created with the stateful set. When I create the pods with the stateful set, random ID is giving or sticky identity is given for the pods. Sticky ID. What are the sticky IDs it has given? 0, 1, 2. So 0 is called as first which pod is created. Can you see the timing also? First, which pod is created now? 0th pod is created. Why 0th pod is created first? 0th pod is called as primary pod. From that primary pod, these two secondary pods are created. So with this, we can see the sticky identity is available. With this, we can see sticky identity is available. Are you guys clear? Sticky identity is available. Now I will go for scale down. Now I will go for scale down. So if I scale down, which one will be deleted first? 0th pod or first pod or second pod? If I scale down, which pod will be deleted first? Second pod will be deleted. Why second pod will be deleted? Why second pod will be deleted? Reverse order. Reverse order. Got it. Now let us see kubectl get a stateful set. Kubectl get a stateful set. Now for the stateful set here, this is the name I have given for the stateful set. 3 out of 3 pods are running. Now let me scale down kubectl scale stateful set. Kubectl scale stateful set. This is the stateful set name. --replicas 2. So currently, when I execute kubectl get pods, 3 pods are running for the database. 3 pods are running for the database. When 3 pods are running for the database, I'm trying to decrease the pods. I'm trying to scale down the pods to 2. Kubectl scale stateful set. Kubectl scale stateful set. This is the name of my stateful set, replicas 2. Now, stateful set got scaled. After it got scaled, let's get the pods. Now, which pod is deleted? Is it deleting the pod in the random order or it is deleting the pod in the reverse order? Is it deleting the pod in the random order or it is deleting the pod in the reverse order? It is deleting the pod in the reverse order. If I go for the deployment, what happened? Random order. So you understand what is the difference between deployment and stateful set? Guys, what is the difference between deployment and the stateful set? Deployment will create the pods with the random ID. Deployment will scale down the pods in the random order. Deployment pods are stateless pods. Stateful set will create the pods with the sticky identity. Stateful set will scale down the pods in the reverse order. Stateful set pods are the stateful. That means these pods will maintain the data. These pods will lose the data. So now tell me when to go for deployment approach and when to go for stateful set. When to go for the deployment and when to go for the stateful set. For the DB deployment, we will go for the stateful set. For the application deployment, we will go for the deployment. Stateless applications and stateful applications. Now, Kubernetes official documentation is available. So Kubernetes.io website is available. Run a stateful application. Okay. So they are also telling how to deploy MySQL database. Now, in order to deploy the MySQL database, first they are creating the config map. Okay, guys. Then after that, they are applying the config map and they are creating a service. Now here, guys, whenever we are deploying our application as a stateful set, what is the cluster IP they are giving here? What is the cluster IP they are giving here? None. When they are giving the cluster IP as client service for connecting any MySQL instance as read for writes, you must instead connect to the primary MySQL-0.MySQL. Now here, whenever they are deploying that MySQL DB as a stateful set, they are giving cluster IP as a none. When they give the cluster IP as a none, that service is called as a headless service. So in the interview, they will ask this question, what is headless service? So earlier, we created 3 types of services. One is a cluster IP, another one is a node port, and another one is load balancer. But when you go for DB deployment with the stateful set, we will deploy our DB as a stateful set and we will expose DB ports as headless service. That means IP address will not be available. I don't want to give the IP address for my database ports. That is called headless service. Headless service. In the interview, they will ask you what is a headless service and how you will deploy your database in the application. To deploy our database in the application, we are going to use a stateful set and the database ports will be available as headless service. How to specify headless service? By using the service spec cluster IP none. When you specify cluster IP as a none, then IP address also will not be available. Only the service name will be available. So earlier, the service is exposing as a load cluster IP or node port or load balancer. But when it comes to the stateful set, we are going to deploy our ports and we will expose the ports as headless service. That means IP address we don't give for the service which is pointed to our DB as a stateful set. So to security reasons, we are not going to generate the IP address for the databases because nobody should access our database. Our database should be accessed only with the name. So how to make our DB deployment as a stateful set? By using kind as a stateful set. Are we going to expose the ports with the cluster IP, node port, load balancer? No. For the DB, always we need to make it as a stateful set with a headless service. How to make our stateful set ports with the headless service? In the service manifest, we are going to specify cluster IP colon none. Service type is not there here. Cluster IP colon none will be available. When you mention the cluster IP colon none, that will become headless service for the stable DNA entries of stateful set members. All the stateful set members will not have any IP address because I don't want to give that. And here, whenever we deploy the DB with the stateful set with the 3 replicas, one replica will be called as a primary replica, other 2 replicas will be called as the secondary replica. The primary replica is used for the writing operations and the primary pod will be used for the writing operations on the database. The remaining 2 will be just dummies for reading the data. Whenever you scale down your stateful set, it will delete the pods from the reverse order. If you go for the deployment, random ID will be available. Deletion also will happen in the random order. But when you go for stateful set, sticky identity will be available. Deletion will happen from the reverse order. And remember, whenever we are going for stateful set, we will specify in the service manifest cluster IP none. When you specify cluster IP as none, that will become headless service. Only with the service name, we can access the database, but not with the IP address. Are you clear? What is the deployment and what is stateful set? Are you clear with what is deployment and what is stateful set? So here we understood stateful set. Stateful set is used to deploy stateful containers. Generally, database deployment will happen with the stateful set. And whenever we deploy the database with the stateful set, don't expose that database as a cluster IP or node port or load balancer. Always our database ports will be available as a headless service. Headless service, nothing but IP address will not be available. Only with the service name we can access the database, but not with the IP address. That is a headless server. Head will not be available for that. Okay, guys. Are you clear? Are you clear with the stateful set? Yeah. How to make our manifest with the stateful set deployment? So here, if you see, I have edited that YML file. Earlier, that YML is having kind as a deployment. Now I changed the client to stateful set. I changed the kind to stateful set. When I change the kind to stateful set, it is asking the service name as MySQL. And here we need specifying type as a cluster IP. So here we should not specify the type as a cluster IP. We should specify cluster IP as none. Under spec, we will specify cluster IP as none. What is the meaning of cluster IP is none? What is the meaning of cluster IP as none? Under the spec, cluster IP colon none we are specifying. What is the meaning of that? If I specify cluster IP is equal to none, that will become a headless service. Cluster IP colon none we are going to specify in the services spec. In the services spec, we are going to specify cluster IP as none. Good. Fine. Now let us reapply this file. kubectl, apply this. Now parsing did not find expected key. Line number 8. YAML line number 8. Cluster IP. Cluster IP. Correct only, right? Cluster IP colon none. In the spec, I'm giving ports. Port name is there. Selector is available. API version is V1. Kind is service. Metadata name. Labels are there. Spec ports name. MySQL port 3306. We don't need this. Target port not required. This is also not required. Now, under the spec, okay, let me save this. None must be a valid IP address. Invalid value none must be a valid IP address. Okay, let me edit that file. Must may not change once set. The service is invalid, spec invalid value, string none may not change once set. Already the service is configured, guys. That's why it is saying that it cannot be changed. kubectl get service. Let me delete the service. kubectl delete service. Shopify app db service. Service got deleted. Now service is created. Once the service is created, kubectl get service. kubectl get service. Right. Perfect. Now, when I go for kubectl get service, earlier you see for my database, cluster IP is available. Cluster IP is available. After that, I changed that to the headless service. When I change that to the headless service for the database, do I have any IP address now? Now the IP address coming as a none. Why we are making this as a none? I want to make my database as a headless service. I don't want to give any IP address for accessing that. I don't want to give any IP address for accessing that. Now, if you see kubectl get SVC, when I get the service, database service is having a cluster IP and IP address is also available. With this IP within the cluster, we can access that. But I don't want to do that. I want to make it as a headless service. To make that as a headless service, we are giving cluster IP as a none. When I give the cluster IP as a none, then for the database service, cluster IP available as none. So once the service is created, that we can't modify. That's why I have deleted that service. I modified the configuration file and I have recreated that service. When I recreate that service is coming as headless service. What is the meaning of a headless service? Making the cluster IP as none. That is called headless service. For stateful set, we will go for headless services. Now, this is my manifest YML, which I have used for this. kubectl vi db deployment YML. This db deployment is happening as a stateful set along with the headless service. Yeah, I will take this file and I will share this file, guys, how to deploy database with the stateful set and how to make our service as a headless service. I will give this manifest YML. Good. So in the tomorrow session, I'm going to explain what is daemon set. What is the daemon set that we will discuss in the tomorrow class. So please practice this stateful set example. So delete the database deployment that we have yesterday and recreate the database deployment, delete the service and delete the database deployment, then create database as a stateful set and make it as a headless service. Right. Thank you, guys. With this, I'm stopping for today. We'll meet in the tomorrow's class. Tomorrow we'll talk about daemon set in the Kubernetes. Thank you.